Hello everyone! In this part of the tutorial, we will create the actual drone, which is going to be summoned by the terminal. Let's start by creating a folder for it. And as our SpyDrone, we are going to use the EndBoss Drone. We have 3 drones to choose from, and we are going to go with the easy, so the default one. For that, we need the EndDrone character blueprint. Also, we will need these 2 materials. We will use one for when the drone is active and one when it's inactive. And we want also a copy of the status component. So select all these 4 files and copy them to mod folder. Rename all of them accordingly. Once finished, let's set up our character blueprint. As you can see, it has already some graph work on it. For now, we will leave it be, but later on, we will have to make some changes here. The first thing we are going to change is override the material on the skeleton mesh to use one of the active and inactive materials we copied. We're going to now replace the status component. Just add the new one and delete the old one. Save and compile. And we see there is an issue. Open the graph and see the compiler result message at the bottom. We see that it couldn't find the function getEndBossColor. This can happen when you create a copy of a blueprint. The reference to a certain object gets lost and we can't find that particular function of that object. And in most cases, just a right click and refresh node will solve the issue. Save, compile. We got ourselves a new drone. Now let's summon the drone using the terminal. For that, open the terminal blueprint and go to the graph section. And we are going to do that on the event begin play. This executes when the structure is spawned into the game world, client side or server side. So the first thing we need to check is it the preview structure, since that triggers the event begin play as well. To do that, we just check the property is preview structure. If it's not a preview structure, we want to check to see is the event begin play executed by the server or by the client, since we want our logic only to run on the server side. And I will show you 2 ways how to summon a dino. First, we are going to use the spawn actor. In there, we need to reference our SpyDrone class and make sure we are calling this only from a dedicated server and a player server, but not from a client. Now we need to know the location where we want to summon the drone. For that, let's go back to the components and add a box, which will be used as our drone landing zone. Position and scale it accordingly. Our drone will be summoned in the center of the box. And to do that, we're just going to get the reference to the box. And get the position relative to the world. Let's test what we have so far. And you see our drone has bad temper, so we need to fix that. Our drone is just like a normal dino, so it can be wild or tamed. And we need to set that this drone is tamed by us. We're going to do that by setting its owning player ID to match the terminal. And do the same for the targeting team. And when we do that, at the end, we just need to call tame dino. And we see here a few options like ignore max tame limit and override taming team ID, which we could use. But the most important one is a reference to the player controller. So the player who will own this dino. Our problem here is that the terminal itself doesn't have a reference to the player itself. So we need to get the reference on our own. For that, let's create a function. We're going to call it getControllerById, which will take an integer, the ID, and return a reference to the controller. Inside the function, we are going to call getAllControllers. And this node itself needs a reference to the shooter game state. So let's get that as well. Once this is ready, we are going to loop through each of the found controllers and search for the matching player ID. And in case we found a matching ID, we are going to store the reference in a local variable. And right after that, break the for loop, so we don't need to continue searching for the player as we have found it. And we are going to return the stored reference from the local variable. Once done, let's go back to the event begin play and use our new created function there. And don't forget to recompile the blueprint once you create or change a function. By using isValid, we are checking if the returned controller is a valid one and not a null pointer reference. We will also need to add a small delay so that the drone doesn't get summoned instantly when the structure appears, but has a small delay to it. And also let's print out a message in case we didn't find a valid controller. Save, compile, and let's do a test. And we see that it still behaves like a dyno for the EndBoss Drone, which is not what we want. And also the drone is much bigger than we need it to be, so we need to fix all of this. First, let's fix the size. So we go to the components section, select our skeleton mesh, and change the scale. We want it to be a fourth of its original size. And if you do that, don't forget to change the size of the capsule component. And center the mesh inside the capsule component. With that, we have fixed the size issue. Now let's change the behavior of the drone. We're going to clean up a little bit of the existing graph, remove the stuff we don't need, like the change of the color to match the EndBoss. As a tip, if you have a return node without any return parameter, you can get rid of it by just adding an output and then removing it, and it will disappear. Let's do a quick test. And we see the size issue and the material issue is resolved, but it still behaves like a dyno. To resolve that, we are going to remove the AI class from the dyno blueprint. And we are also going to change the way we summon our drone. This is another way you can summon a tame dyno. What makes this a better choice is that this method doesn't prompt the user to name the new tame dyno. For that, we are going to use the node Spain from dyno data. We'll check that it creates a new dyno ID and feed it the targeting team ID. For the in-world, we are going to use k2 getWorld. And to get the dyno data, we are going to use getClassDefaultObject, which will give us the default instance of that dyno. We will need to cast it to our primal dyno. And then use the getDynoData to extract the dyno data and feed it to inDynoData. And that's pretty much it. For this method, we don't need a player controller. Save and compile. And before we run a test, let's check the other properties and see if we need to change anything else in here. Most of the stuff we are going to leave as is and get back later to it. For now, let's just change some of the obvious. And save the changes. And the last thing we need to do is disable the server timer logic, which is responsible for the drone getting away from us if we come from the front. Let's do a test play. And we see the drone is not running away from us anymore. But one last thing we have left to fix is the multi-use menu. We don't want any. So the simple solution for this is just to disable the multi-use entries on the drone blueprint. And all done. this is it for this part of the tutorial. See you in the next one.